Engineering is the art of controlling nature. We build massive structures, we drill miles into the earth, and we split atoms to power our cities. But when engineering fails, the bill is not just paid in dollars, it is paid in destruction. Sometimes a single loose bolt, a misunderstood unit of measurement, or a lazy design change can trigger a chain reaction that wipes billions of dollars off the map in seconds. Today, we are counting down the top 5 most expensive industrial disasters in history. From a simple math error that drained an entire lake, to the safety test that turned a nuclear city into a ghost town. I'm Build and Rise Network, and this is why details matter. At number 5, we have perhaps the strangest disaster on this list. The day an oil rig flushed a lake like a toilet. It was November 20th, 1980, Louisiana. On the surface of Lake Peigneur, a Texaco oil rig was drilling for black gold. Directly underneath the lake, miners were working in the Diamond Crystal salt mine. The engineers on the rig had calculated their position using triangulation, but they made a fatal error. They didn't account for the curvature of the coordinates correctly. They were drilling in the wrong spot. At 4:30 a.m., their 14-inch drill bit seized up. They thought they hit rock. Actually, they had punched a hole into the roof of the salt mine below. Fresh water started rushing into the salt mine. And as anyone who knows chemistry can tell you, water dissolves salt. The tiny 14-inch hole grew into a massive crater. The lake began to drain into the mine. It created a whirlpool so powerful it sucked in the drilling platform, 11 barges, a tugboat, and even 65 acres of the surrounding forest. It actually reversed the flow of the Delcom Canal, causing a waterfall to flow backwards into the crater. Miraculously, no one died, but a $100 million mine and an entire ecosystem were destroyed, all because of a trigonometry error. Number 4 is the deadliest structural failure in U.S. history, and it is taught in every civil engineering classroom in the world. In 1981, the Hyatt Regency in Kansas City was the place to be. It featured these elegant suspended walkways hanging from the ceiling, held up by steel rods. But during construction, a contractor proposed a subtle change. The original design called for a single long rod to hold up both the second and fourth floor walkways. But long rods are hard to manufacture, so they changed it to 2 separate rods, one connecting the ceiling to the fourth floor and another connecting the fourth floor to the second floor. It looked harmless. It wasn't. This change doubled the load on the connection nut of the fourth floor. It was now carrying the weight of both walkways. Nobody recalculated the load. On July 17th, during a tea dance, the nut sheared through the box beam. 2 walkways crashed down onto the crowded lobby. 114 people lost their lives. It was a failure caused not by weak materials, but by a lack of communication in the design process. Number 3 takes us to the freezing waters of the North Sea. Piper Alpha was a monster. It produced 300,000 barrels of oil a day. It was the pride of the industry. Until July 6, 1988. During the day shift, a safety valve on condensate pump A was removed for maintenance. The pipe was sealed with a temporary blind flange, a flat metal disc that was not perfectly tight. The engineer filled out a permit stating, "Do not start pump A." But here is the failure. The paperwork was lost during the shift change. When the night shift came on, pump B failed. They needed to restart the system. They looked at pump A. They didn't know the valve was missing. They didn't see the warning. They hit the start button. High-pressure gas hammered into the blind flange. It leaked. It ignited. The resulting explosion set off a chain reaction that melted the gas risers. The platform was engulfed in a fireball visible from 100 kilometers away. 167 men died. It remains the worst offshore oil disaster in history, proving that paperwork is just as important as steel. Number 2 is the disaster that poisoned an ocean. April 2010. The Deepwater Horizon rig in the Gulf of Mexico. They were finishing a well called Macondo. They were behind schedule and over budget. To seal the well, they pumped cement to the bottom, but the cement didn't set properly. Engineers ran a negative pressure test to check for leaks. The results were weird. The pressure was rising when it should have been zero. Instead of stopping, they interpreted the data as a bladder effect, a false positive. They ignored the warning. They began to displace the mud with seawater, but the seal had failed. Methane gas shot up the riser pipe. It bypassed the blowout preventer, a massive 300-ton safety valve that failed to cut the pipe because the drill pipe had buckled. The gas reached the engine room. Boom. For 87 days, oil gushed into the Gulf of Mexico. BP ultimately paid over $65 billion in fines and cleanup costs, all because they rushed a pressure test. And finally, at number 1, the name that defines catastrophe: Chernobyl. We all know it exploded, but as engineers, we need to ask, why? Ironically, they were trying to run a safety test. They wanted to see if the spinning turbine could power the cooling pumps in a blackout. To do the test, they disabled the automatic shutdown systems. Then, they made a mistake. They let the reactor power drop too low, which built up xenon poisoning in the core, making it unstable. To fight this, they pulled almost all the control rods out. When the test started, the power surged uncontrollably. The operator, Akimov, slammed the AZ5 button, the emergency shutdown. This should have saved them. Instead, it killed them. The control rods had fatal design flaws. They had graphite tips. Graphite increases reactivity, so when the rods entered the core, instead of stopping the reaction, they spiked it. The reactor jumped to 30,000 megawatts. The lid blew off. The cost of Chernobyl is incalculable. It bankrupted the Soviet Union. It turned a city into a tomb for 20,000 years. It is the ultimate reminder that in engineering, you cannot cheat the laws of physics. From the salt mines of Louisiana to the control room of Chernobyl, these disasters share one haunting reality: they were all preventable. We often think of engineering as just math and steel, but as we saw today, the weakest link in any system is rarely the metal. It is the human being. Whether it was a desire to save money on a hotel walkway, the pressure to finish an oil well on time, or simply forgetting to read a safety tag on a pump, physics punished those decisions without mercy. The $150 billion lost in these 5 events is staggering, but the loss of trust is even harder to rebuild. It forces us to ask, are we designing systems that can survive our own mistakes? I want to hear from you. Which of these 5 disasters do you think was the most unforgivable? Was it the negligence at Deepwater Horizon, or the design shortcuts at the Hyatt Regency? Or is there another engineering failure I missed that deserves a spot on this list? Let me know in the comments below. If you are fascinated by the mechanics of disaster, make sure to hit that subscribe button and turn on notifications. This Saturday, we are going to dive deep into a building collapse so sudden it trapped thousands of people in seconds. You don't want to miss that. I'm Build and Rise Network. Respect the physics, stay curious, and stay safe. I'll see you in the next one.